All right, welcome to your stats warm-up. Can you use IQ scores to predict a student's GPA? Probably not. That's not going to stop us from trying. All right, so what do we have here? We have the average IQ score was 108.9 with a standard deviation of 13.17. GPA is being measured on a 12-point scale, where the average GPA was 7.447 and the standard deviation was 2.10, and the correlation between those two variables is 0.6337. So what we have there is all of the information required to come up with a regression equation. And lucky us, that's exactly what the question's asking us to do. All right, so our formulas. The slope of a regression equation is equal to R times SY over SX. The y-intercept of a regression equation is equal to y bar minus the slope times x bar. All right, so obviously we're going to have to do this formula first, since this one requires the information that we get up here. All right, so R was told to us to be 0.6337. S of y. Now, which ones are y, which ones are x? It says we're using IQ scores to predict GPA. So that makes IQ scores are x. It makes GPA our y. All right, whatever we're using to make the predictions is our x. Whatever we're trying to predict is our y. So the standard deviation for the GPA was 2.10. The standard deviation for the IQ was 13.17. All right. So at that point, it's just a matter of putting it into your calculator. So 0.6337 times 2.10 divided by 13.17. And we get a slope of, we'll say we'll go 4 decimals here. 1010. All right. Now that we have that slope, we can find our y-intercept. All right, so our y-intercept is y bar. So that's the average GPA of 7.447 minus the slope, which we saw was 0.1010, times the average of x, and the average IQ score was 108.9. So again, at this point, it's just calculator work. So 7.447 minus 0.1010 times 108.9. And we're ending up with negative 3.5519 equals negative 3.5519. Now, make sure that you don't stop here, all right? Yes, you've got both pieces, but you actually haven't written the equation yet. So again, the equation is predicted y equals a plus bx. Now again, this is just the stats way of writing it. If this confuses you, just think of y hat equals mx plus b. Either way, the number next to the x, whether you call it b or m, is the slope. The number all by itself is the y-intercept, just like it has always been. All right, so again, I don't care whether you write it y hat equals negative 3.5519 plus 0.1010x, or if you write it y hat equals 0.1010x minus 3.5519. All right, they're the same equation. Doesn't matter to me which one you do. Again, this is the way you usually see it in a stats book. Obviously, this is the way you've been seeing it your whole life in like algebra and stuff like that. All right. Garry Kasparov is one of the world's greatest chess players. His IQ is 194. What would we predict for Gary's GPA? Does this result make sense? What do you think is happening? All right, so now that we have our regression equation, we can make a prediction. So we can say that y hat equals negative 3.5519 plus 0.1010. And then we're just going to plug in Gary's IQ there and see what it works out to be. So negative 3.5519 plus 0.1010 times 194 gives us a predicted y of 16.0421. Now, does that result make sense? Not really, all right, because we said that an A plus was a 12. So if an A plus was a 12, that would be a 13, a 14, a 15, a 16. So unless Gary got an A plus 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 plus, the result doesn't really make sense. Doesn't make sense. Because we are extrapolating. All right, it's unlikely that our data set went as high as 194. So chances are the model that we're using is not a valid model to use for somebody that has an IQ this high. All right, so when you use a model outside of the range that you have data on, you're likely to get a ridiculous answer, which is what happened here. All right, so again, you need to only be using your equation where you have data. And this was probably not part of our data set because it's a pretty rare IQ. All right. What IQ would we expect for a student with an A plus GPA? Again, this is just using our equation in reverse. We said that an A plus up top here was a 12. All right, so 12 equals, and then negative 3.5519 plus 0.1010x. So we're just using the equation in reverse. And again, I don't need you to show me every single step here. If you just do the whole thing on your calculator, I'm fine with that. So if you're just like 12 plus 3.5519 and then divide by 0.1010. All right, if you skip right to x equals 153.9792, or if you write just 154, or if you write 153.98 or 154.0, whatever, as long as you round it correctly, I'm fine with that. All right, but we're basically just plugging this in for the predicted y and then using that and solving it as a pretty basic equation. All right, so this is more of the new stuff, but you should still be able to do something like this. All right, something like this shouldn't in any way be a problem. All right, let's take a look at the back. So this one deals with pie consumption at Thanksgiving, and how much food you eat at Thanksgiving corresponds to how much pie you then consume. All right, so right here we see the average pounds of food consumed was 2.3 pounds with a standard deviation of 0.74. And then the average number of pies was 1.6. Not pies, pieces of pie, sorry, with a standard deviation of 0.37. And the correlation here is negative, which makes sense. As you eat more food, you're probably going to have less pie because you're going to be full. As you eat less food at dinner, you're probably going to have more pie because you left space for it. All right, so that's what that negative correlation is kind of suggesting in like a real world setting. So find the equation for the least squares regression line. This is basically just doing what we did on the front there. So again, you need to have your two formulas. So the slope of a regression equation is r times sy over sx. And the y-intercept for your regression equation is y bar minus the slope times x bar. So again, we have to start here because we need that information for right here. All right. So if we look at the question, it says we're trying to predict pieces of pie based on pounds of food consumed. All right. That means pounds of food is going to be our x, and pieces of pie is going to be our y. And so when we're calculating the slope, we're going to be negative 0.57. The y goes on top, just like it does with a regular slope, change in y over change of x. So that's 0.37 over 0.74. And then let's just bring that over to our calculator. So negative 0.57 times 0.37 divided by 0.74 gives us a slope of negative 0.285. So there's our slope. Now that we have that, we can use it in our y-intercept equation. So we've got y bar, which is 1.6, minus, now be careful, you don't want to make like a silly algebra mistake here, but you're subtracting negative 0.285 times, what's the pounds of food? 2.3. All right, so just make sure that you kind of keep all of your negatives straight on this one so that you don't make a silly mistake. So you've got negative 0.285 times 2.3 is negative 0.655, but when you subtract a negative, it's obviously going to become positive. So this is going to be 1.6 plus 0.6555. All right, so again, don't be the kid that makes that silly mistake and goofs up the negative there. So let's take that, this is 0.655, we're going to add it to our 1.6, and that's going to give us 2.2555. Now, if you stopped here, you would lose points because you haven't actually written the equation. So yes, you have your y-intercept. Yes, you have your slope. I still need to see the actual equation. So again, whether you do it the stats way or the algebra way, it doesn't matter to me as long as you remember to actually plug those numbers back in. So you've either got y hat equals 2.2555 minus 0.285x, or you've got y hat equals negative 0.285x plus 2.2555. So again, I don't care which way you do it. Just make sure that you don't forget to do it. All right, don't do all the hard stuff and then forget to do the easy stuff. So if a person ate 2.5 pounds of food and 3 pieces of pie, what's the residual associated with this data point? So a reminder that the residual is the actual minus the predicted, right? The actual, we know, they ate 3 pieces of pie. The predicted, we have to actually calculate. So we're going to need to use our equation. Y hat equals 2.2555 minus 0.285 times x, which they told us is 2.5. All right, so I'm just plugging 2.5 into my equation. bring it over to my calculator here. 2.2555 minus 0.285 times 2.5 is 1.543. So basically a piece and a half. So the actual amount of pie they consumed was 3. We predicted that they would only consume 1.543, which means our prediction was too low. And our residual is just 3 minus 1.543, or 1.457. All right, so this right here is our residual. Okay. How many pieces of pie would we predict someone would eat if they only had half a pound of food for dinner? So this is somebody that's like really trying to keep the dinner to a minimum so that they can have as much pie as possible. So what would that look like? Again, we're just using our equation in reverse. So y hat equals 2.2555 minus 0.285x. This time we're going to use this half a pound. Plug it in here. Yeah, I don't know why I said this is reverse. This is a straightforward one. All right, so y hat equals 2.2555 minus 0.285 times 0.5. So again, now we're just to the calculator part. 2.2555 minus 0.285 times 0.5 is 2.113. So basically, we expect them to have 2 pieces of pie and then maybe try a forkful of somebody else's. Okay. So again, these are the easy ones where you're just plugging things in. But you do need to know how to do this. All right. You do need to know how to take these pieces, put them together to make a regression equation. And then you also need to know that a residual is actual minus predicted and not predicted minus actual. All right. So I hope this was helpful. Again, as always, reach out if you have questions, and I'll see you when I see you. Bye.